Section 2.2, example 2, solving an equation algebraically when the variable appears on both sides. So solve the following equation. We have 4 times x minus 3 plus 12 is equal to 15 minus 5 times x plus 6. Okay, so to start off this equation, I see a couple of different things. There's a lot of stuff going on both sides. We have variables on both sides. So to start off with, we always want to end up with x is equal to our solution. So let's get everything with the x over to one side. But before we even do that, x is not really by itself here yet. So what we're going to have to do is distribute here and distribute over here too. So let's rewrite this problem. So 4 times x minus 3 plus 12 is equal to 15 minus 5 x plus 6. Starting off with this 4 is going to multiply with everything inside those parentheses. So 4 times x gives us 4x. 4 times negative 3 gives us negative 12. And we finish that part, so we're going to rewrite the rest of the left side. And let's work on the right side. 15 times, here it's not just a 5 that we're distributing, it's this whole negative 5 that we're distributing to these two, because we're subtracting all of that. So might as well distribute that negative through. So we have negative 5 times x, negative 5x, and we also have negative 5 times 6, negative 30. And now before we move things over, I see that we could simplify on this side. We could also simplify over here on this side. So combining like terms, we have 4x because the 12 subtract out. 15 minus 30 gives us a negative 15 minus 5x. And now in the previous problem, what we did is we moved, we had the variable over on the left side. So I think it would be really easy to move this over to this left side. So to move it over, we're going to do the opposite of the sign. So we have a negative 5x. So what we're going to do is add 5x to both sides. 5x and negative 5x subtract out. And that leaves us with 9x is equal to a negative 15. And lastly, to get x by itself, we're going to divide both sides by 9 because this 9 is being held together with this x using multiplication. Opposite of multiplication is division. So dividing both sides by 9. X is equal to, we keep the sign of the negative. And I do know that both of these are divisible by 3. So 15 divided by 3 is going to give us 5. 9 divided by 3 is going to give us 3. And it doesn't look like it simplifies any further than that. So we have x is equal to a negative 5 over 3. And there we go. If you want to check to see if it works, we could definitely do that. So we have the problem for x minus 3 plus 12 is equal to 15 minus 5 x plus 6. And we just learned that x is equal to a negative 5 over 3 minus 3 plus 12. 15 minus 5 times negative 5 over 3 plus 6. A little recap: when we're adding fractions and whole numbers, or when we're adding fractions together, we want to rationalize them. So we could put this over 1. So that way we could get a denominator of 3 on that second fraction. Six over 1. And notice I left a little space. So to get the denominators looking the same, we're going to multiply both top and bottom by 3. on that second fraction. And same thing over here. To get those two denominators looking the same, we're going to multiply the top and bottom by 3. So 3 times 3 is 9 over 3. 15 minus 5 times negative 5 over 3. 18 over 3. And add inside the parentheses first. So negative 5 minus 9 gives us negative 14 over 3. And here it's going to be positive 13 over 3. 4 times negative 14. negative 56 over 3 plus 12. We'll put this over 1, so we could do the fractions here in a minute. And negative 5 times 13. That's 5. 65 over 3. And multiply top and bottom by 3 here. And here as well. So negative 56 over 3 plus 36 over 3 is equal to 45 over 3 minus 65 over 3. Negative 56 plus 36 is going to give us a negative 20 over 3. 45 minus 65, negative 20 over 3, which are exactly the same. So it holds true. X is equal to a negative 5 over 3. I know it was a lot, but I'm glad that we could get a little recap on fractions here. If you have any questions, please feel free to ask. If not, bye.